Hi everyone, so today we're going to start lesson 7. You are going to need Wii Scheme, so make sure that you have that open and that you're logged in and ready to go for when we get to the spot where you need to enter things into your computer. So in number 1 here it says type each of the following into your interactions window and press enter. What does each expression evaluate to? So I'm going to do these for us just so we can all do this together, be on the same page. But what I want you to notice is that in all 3 of these codes, they're all different than what we've worked with so far. Instead of an addition sign or a division symbol or whatever, we see a greater than, a less than, and an equal sign. So these are going to be something a little different than what we're used to. So in Wii Scheme, I'm just going to open a new program. So we have less than 3, 4. I press enter, we get the statement true. My second one, I have greater than 3, 4. We get the statement false. And then my last one is equals 3, 4. That is also false. So instead of getting a numerical answer, we got a statement, true, false. Okay, so this first one was true. And these two were false. All right, so we've already talked about 3 of our 4 data types. Today we're going to talk about that 4th data type. So in number 1, we get outputs that are not numbers, strings, or images. So what type of data is it? And this is called a Boolean. And Booleans are answers to a yes or no question. Boolean values can only evaluate to true or false. So a Boolean will not be something that can't be used as a true or false answer. Okay? So we are going to convert each of the following math sentences into code, and then we're going to state its Boolean value, whether it would be a true statement or a false statement. So my algebra here is 10 equals 16.1. So my code would be parenthesis equals 10, 16.1. Okay, so parenthesis equals 10, 16.1. False. Which hopefully is easy for you to understand because 10 and 16.1 do not equal each other. All right. Negative 13 is greater than 5. So we add a parenthesis, greater than, negative 13, 5. So into Wii Scheme, parenthesis, greater than, negative 13, 5. False. All right, the next one. 40 minus 1 is less than 90 times 2. So parenthesis, less than is my function. We're doing 40 minus 1, so I have to start my own code, minus 41. And we're trying to compare that to 90 times 2. So multiply 92, 2 parentheses. So into Wii Scheme, less than, minus 41 times 92. True. All right, and then the last one, 0 equals negative 5 plus 10. So equals 0 plus negative 5, 10. Equals 0 plus -5, 10. False. All right. Complete the contracts below for less than, greater than, and equal to. So my contract for less than, I would need two numbers. 3 is less than 4. When I do that, we get a statement, true or false. So that would be a Boolean as my range. Greater than, same thing. I still need two numbers and I would still get a true or false answer. So my range is a Boolean and equal is the same. I still get a true or false answer. So my range is a Boolean. So now we have 4 types of data: a number, a string, an image. Those are the 3 we've talked about already, right? These are the 3 we should know. And then today we're learning Boolean. That's true or false statements. Okay, so on the next page, this is where you are going to need Wii Scheme. So again, make sure you are all logged in and ready to go. And once you're logged in, you need to type this link into the browser and it should open a Wii Scheme program. Okay, so when you copy that into your browser, this is the program that should come up. Okay, so the first step of this says click remix. In order to save this in the future, just click save. The file name can stay Cage. So you should see Cage is in the project name. So I'm just going to click remix so that it saves it. And then when it reloads, now it says save instead of remix. Okay. All right. Number 9 says now click run. So here we have a butterfly. So some things to know about this program. The window that pops up contains a butterfly named Sam. When the program begins, what are Sam's coordinates? So up at the top, you can see the coordinates here. So it says the x coordinate is 320, the y coordinate is 240. So we have 320, 240. Sam's yard, which is the boundaries of the screen, so that box, is 640 pixels wide by 480 pixels tall. You can move Sam around using the arrow keys, which you see I'm pressing the arrow keys on my computer. So as I'm doing that, I want you to notice how the x and y coordinates are changing depending on how I'm moving. Okay? The x and y coordinates change depending on the direction. So Sam is free to fly around the yard, and the coordinates at the top of the screen update to tell you his location. What happens when you move Sam past the edges of the yard? Does he stay on screen? Let's see. Nope. So I moved him past the edges. His coordinates are still changing, but I no longer see him. So the answer to that question is no. All right. Sam's mother tells him that it is okay for him to step outside of the yard, but only by a short distance. Specifically, she wants to make sure that she can always see at least a little piece of his wing. Sam is safe as long as part of his wing is on screen. Your task will be to write the code that will keep Sam on screen and safe. So what I want you guys to do is play around with Sam, and I want you to figure out what is the first x coordinate on the left side of the screen. So if you move Sam all the way to the left, what is the first value of x where you cannot see any part of Sam? Okay. Same thing for the right-hand side. When is the first x value that you cannot see Sam on the screen? Okay, so take a second and see if you can come up with those answers, and then come back and check your work. Okay, so since I'm on the right here, let's see. So I can still see Sam. Still see Sam. When I go one more, he's not there anymore. So 680 is the last one I can see him. So 690 is the first one on the right that we're not going to work. So 690 Should hopefully be what you wrote on the second line. Now, if we go all the way to the left, we're going to do the same thing. So I still see Sam there, negative 40. I go one more, I can't. So negative 50 is my left-hand side of the screen. So using the x coordinates from number 10, write two inequalities using less than or greater than that will keep Sam safe. In other words, Sam's wing is still visible on the left side of the screen as long as we think about this. Negative 40 is the last time I can see him, and all these x values are bigger than negative 40. So my inequality here is going to be x has to be greater than negative 50. Okay, the same thing would be true for the right-hand side of the screen, right? 690, I can no longer see him. So x has to be less than 690. So my x value has to be somewhere between those two numbers for us to be able to see Sam. Now, unfortunately, right now there is nothing to keep Sam from leaving his yard. Look at the code for the cage program and fill in the names for the three functions involved. So if we look at the code here, we're going to X out of this. On the left-hand side here, in the definitions window, we have safe left, safe right, and on screen. Those are those three pink sections on this side over here. Okay, so safe left, safe right, and on screen. All right. Okay. Now, right now, all three functions return true no matter what Sam's x coordinate is. This needs to change. So we're going to write the code for the safe left function. So the safe left function is going to take in an x coordinate and checks to see if it is greater than negative 50. So the name of my function is safe left. And it's going to take in a number, an x coordinate, and it's going to check to see if it's greater than negative 50, meaning it's going to tell me true or false. So the range of this is a Boolean. That's my new type of data. Okay. My purpose statement is going to determine whether a given number is greater than negative 50. Okay. So for example, we could have safe left 30. So we would be checking to see if 30 is greater than negative 50. So greater than 30, negative 50. Okay. Another example, safe left. Maybe this time we do a negative number, negative 80. And again, we're checking to see if negative 80 is greater than negative 50. Okay. So we have to circle the part that's changing, which is our two numbers here, and we got to give it a label. These numbers represent the x coordinate of Sam. So let's just call it x. So my definition, we are defining safe left. Oops, I forgot my question marks. As x, that's my variable. And then my function is greater than x, negative 50. Okay. Make sure you have all of that written down. All right. So we are also going to write the code for the safe right function. So that's almost the exact same thing. So we have safe right. that takes in a number and gives me a Boolean. Okay. And the purpose statement for this is to determine whether the given number is less than 690. So it's almost the same thing. So my examples, safe, right? Maybe we do 60. So here we're checking to see if it's less than 690. Safe, right? 240. And again, we're checking to see if it's less than 690. Okay. Same thing, 60 and 240 are my changeable parts. Those represent the X value of Sam. So my definition, we're defining safe, right? Using an X value. And my function is going to see if that X value is less than 690. Okay. Now, we want to test our safe left and safe right functions, which means we need to type these into Wii Scheme as a design recipe. So if you go back into your code, oops. So over here on this side here, we need to we're going to delete these out here. And we're going to do a design recipe. So we have our contract, safe left, takes in a number, gives me a Boolean, safe left, what was our first one? 30. And that's going to do greater than 30, negative 50. Safe left, negative 80. Greater than negative 80, negative 50. Define safe left, x, greater than x, negative 50. Insert. Same thing for safe right. Recipe, safe right, number, Boolean, safe right, 60, less than 60, 690, safe right, 240, less than 240, 690, safe right, x, because we're using x values, less than x, 690. All right, so now let's click run. So now if I move Sam to the right, he's still not working, right? I can still move him off the screen. Let's see what happens when I go to the left. He stops. I can't go any further. So we're going to leave you hanging here. Safe left, he is safe. But he's not on the right. Uh-oh. Okay. So this is all we're going to do for today. So make sure you have all this down, save the software so that you can access it later. And I hope everyone has a great night.